So it is related by function, depends on the material parameters. So this is the constitutive function or relation. Just now I didn't see, I've forgotten already, whether it is there in your derivation. You have to recap. It is compulsory to write the chi x1, or when it is 1, this is 1 also. You have to write also. Because remember last week, for the first time when I explained this, I put asterisk to the chi1, but at the end I drop it because I find that when we go to the second order, third order, it becomes very restrictive. To expand it, I mean to split the terms. To split the chi into second order or third order. If we put the omega, then we have no problem. So this one corresponding to the complex function of this. This one reflect the conjugate. You can see the change of sign. You can see the change of sign. Minus to positive, and then positive to minus. Okay, and we all follow the ways. You see, I can ignore the chi here because here I just products of E. I do not say P, right? Because I just want to make my life easy. I can substitute the splitting easier. So I take the products of the E first. And then for the P2, I know that it should respond to two field. So it should respond to two field. So P2, P bracket 2 split into 4 terms like this. So when it's split to 4 terms like this, we naturally insert the chi2. Chi2 follow the convention how to write the arguments of omega. This one got 0, you see? 0 minus omega, omega. Minus omega is because of the field is conjugate. Positive omega because of the field is complex. This is a complex field. This is the conjugate of the complex field. You can see how is it, right? When you see the P, you want to relate to the E field, you must have the chi. All right. So for the expansion of the P third order, bracket 3 is third order in terms of the 3 field. Here I take the product of 3 field together. So you see, I don't write any chi, you see, because it's just product of E field. When you write the P third order, bracket 3 third order, in terms of 3 field, so I just copy paste directly, and after this I insert the chi. Okay, chi 3, following how this is. Right, for example, this is these are all 3 are complex field. So the argument after the semicolon is for all positive omega, and then the resultant time dependence is exponent negative 3 omega. So the negative 3 omega is here. The time is not here. So this function, all these chi function are purely frequency dependence, because the time dependence is carried by the exponent. Okay, these 3 are the amplitude, and so on. When you see the one field is conjugate field, so this frequency related to it is minus omega. You grab it. So you see, and this P1 here, here you cannot escape anymore. The P1 here, you have to write. Because we want to write in terms of E, so your chi must be here already. So this is the P1. So this is another P1. This is another P1. All right. And then after this, you just use your products. You get 8 terms. 8 terms. You get all these 8 terms. And after this, I can substitute term by terms. So for if you want to solve the first order chi, we don't need to substitute the p to the power of 3, because p to the p to the power of 3, you have 3 fields. But here we have only one field, and one field. And this term will carry 3 fields. So this one we will ignore. And the driving field is one field. So we put it in for the first order. And then we solve the first order in yellow. For second order, then the first order we already used. So it's no more first order. When the term you use, you never put it in anymore. This one is third order, it's not matched because here is 2 field, this one is 3 field. So when you solve this thing, there is no source here. You can solve that all the chi IXX, different arguments, all will be 0, right? Because all these are unknown, but here you got nothing 0. And then for the third one, so just now we solved the E3 in terms of chi3, This is in terms of chi3, but E3 field. This all in terms of chi1, but each P1 will carry 1 E field. Powers of 3, so you have 3 E field. You substitute, then you can see something complicated. All right, so this one is the second order time derivative. Okay, this is the first, this is a damping term. So even though I highlight it, it will take a long time. It's really consuming the memory of the system. Still cannot highlight. Okay, and then this is the restoring terms. And then this is the, you can see all the chi1. Okay, so after this is my simplification. As I showed to you last week, as I showed to you last week, we can simplify because we are interested only the terms carry the exponent negative I omega t. So altogether, all the terms will retain only 3 terms. All the bracket will retain only 3 terms. Because each of them will carry the exponent minus I omega t. This also will retain 3 terms. Because only this term, appearance of these terms together with the linear that we have solved just now, then we can see the bistability. Okay, and then this is the restoring terms. All right, also all exponent minus I omega t. This is the nonlinear terms. We also retain the exponent minus I omega t. Okay, so you can see that all these 3 terms actually they are the same. All right, because of when we measure the chi, when we measure the p, resultants from 3x field, we cannot identify the position of the conjugate of ex, whether it is in first position, third position, or the second position. Actually, they are the same. We can simply write 3/8 and retain only 1 term. So let me see. Oh, I didn't do it here, but here is a bit easy. I can copy paste to show to you. So I copy here, and then I put some marks here so that to show that it is different steps. Okay, so when I do this, so actually this first term, second term, and third term, they are the same. As I said, the measurement cannot identify the position of ex. Okay, so I can write 3. Okay, I see that they are the same, so I can delete. Okay, the same as here, this is 3.